going to continue our discussion of volumes. Today we're going to look at the volumes of pyramids and cones. Now the volume of a pyramid is 1/3 the product of the area of the base and the height. So it's 1/3 times the area of the base times the height of the pyramid. And that same formula can be used whether it's a right pyramid or an oblique pyramid, because we can still have the height. Okay. So if we look at this first problem, the entrance to the Louvre Museum in Paris, France is a square pyramid. The base edge is 35.4 meters and the height is 21.64 meters. What is the approximate volume? So again, volume is 1/3 times the area of the base times the height. Now the base, it tells us, is a square, so we're going to do 35.4 squared, because it's 35.4 times 35.4, and that times a height of 21.64. So if we do 1/3 times 35.4 times 35.4 times 21.64, if you're not sure how to multiply by a third, you can do the same thing by multiplying these three numbers first and then dividing by 3. We get an answer of 9,039.46 and so on. Let's approximate the volume. So if we round it to the nearest whole number, we get 9,039. Now our units were meters, so we have cubic meters. So approximately 9,039 cubic meters is the volume of the Louvre Museum in Paris. Now for this example, a pyramid has a base area of about 300,000 square feet and a height of 321 feet. What is the approximate volume? This one's actually really easy because they've done one step for us. All right, 1/3 the area of the base times the height. So 1/3 times the area of the base, which we don't have to figure out because they gave to us, is 300,000 times the height is 321. Now 1/3 times 300,000 is 100,000 times 321, so we have 321 and then the same number of zeros, so we get 5 zeros. Go back and add in our commas. We have 32,100,000. Our answer is in cubic feet. Very big pyramid. Okay. In this example, we now have slant height given rather than the actual height. We know that we have the volume of a square, or we're finding the volume of a square pyramid with base edges of 40 feet and a slant height of 25 feet. Well, volume is 1/3 times the area of the base times the height. Now it's a square pyramid, so the area of the base we know is going to be 40 times 40, or 40 squared, but we need to find the height. Well, again, we have a right triangle. This is half of our side, so we know that's 20. We're looking for the height, so we use our Pythagorean theorem. A squared plus b squared equals c squared to find that missing side. We're given c squared of 25. We're given one of the other sides, and it doesn't matter whether you use a or b. I'm going to let a be my unknown, plus 20 squared. So we have a squared plus 400 equals 25 squared is 625. So a squared equals, subtract 400 from each side, 225. So a is 15. This is also a 3, 4, 5 right triangle, but everything is multiplied by 5. So we have 3 times 5, 4 times 5, 5 times 5. So if you notice that, that's awesome. If not, Pythagorean theorem works every single time. So our height is 15. So now we do 40 times 15. Take that number, divide it by 3, and we find we get 8,000. Our units were feet, so our answer is cubic feet, or feet cubed. Okay. All right, another one for volume. We have a square pyramid with base edges of 24 meters and a slant height of 13 meters. Again, pictures help. Doesn't have to be perfect, right? We just want the idea. Base edge of 24, slant height of 13, but we need the actual height, right? So if we pull out that triangle, which is our right triangle, this here is going to be half of the base edge, so that's 12. Our hypotenuse is 13. The height's the one that we don't know. Now remember, volume is 1/3 times the area of the base times the height. Let's go ahead and plug in what we know. The area of the base, since it is a square pyramid, is going to be 24 squared. And we just need the height. Now you may recognize this as a particular type of right triangle. If not, again, a squared plus b squared equals c squared. C is 13. I'm going to use a this time as 12, and we're going to solve for b. So we have 144 plus b squared equals 169. Subtract 144 from each side, so b squared equals 25, which means b equals 5. So the height of my figure is 5 meters. So now in our calculator, we do 24 times 24 times 5. Divide that whole number by 3. We get 960. Our unit was meters, so our answer is in cubic meters. Okay. Now when we go to find a cone, remember a cone is the same thing as a pyramid, it's just in that the base is a circle. So if we think about volume as 1/3 the area of the base times the height, well, since this base is a circle, the area of a circle is pi r squared times our height, and so that is where the formula comes from for the volume of a cone. So let's look at a couple of examples. The TP that's shown, which isn't shown, but we'll draw it. Here's our TP. It's a beautiful TP. It's 12 feet high with a base diameter of 14 feet. What is the approximate volume? Alright, so volume is 1/3 the area of the base times the height. We know the base is a circle, so it is 1/3 times pi r squared h. So we have 1/3 times pi. Now the radius is going to be half the diameter, so we have 7 squared times a height of 12. We do that multiplication and we get 196 pi. Now we want an approximate area, so I'm going to round to 2 decimal places, and we get 615.75 cubic feet. And now here's a question for us. If the height and radius of that TP are half of the ones above, then what is the volume? So what kind of effect do you think it's going to have? Well, let's find out. 1/3 pi r squared h. Now remember, we're going to take half of everything that we were given originally. So our radius was 7. Half of that is going to be 3.5. We're going to square that. The height was 12. Half of that is 6. We do that multiplication, we get 24.5 times pi, which we approximate to be 76.97 cubic feet. Okay. Now I challenge you to figure out, there is a relation between this number, and it may be easier with this one, and this number down here. I challenge you to find out what that relation is, given that we took, for the height and the radius, we took half of the number. Okay. Now what about finding the volume of an oblique cone? Same formula. Volume equals 1/3 times the area of the base, which is pi r squared, times the height. So we have 1/3 times pi times the radius, which in this case is going to be 15. Square that times a height of 25. Now we're going to give our answer in terms of pi, and we want to round it to the nearest cubic foot. So we're going to be doing 2 different things here. Now when I multiply all this out, 15 times 15 times 25 divided by 3, I get 1875 times pi cubic feet. This is exact in terms of pi, and now if we round it to the nearest cubic foot, so 1875 times pi, we get 5,890 cubic feet. Okay. Here's another oblique cone. Same formula. Volume equals 1/3 times pi times r squared times the height. So 1/3 times pi. The radius in this one is 6. The height is 12. So we have 1/3 times 6 times 6 times 12. We get 144 times pi. Again, we also want this answer rounded to the nearest cubic meter, so we have 144 cubic meters times pi. That's exact. If we round to the nearest cubic meter, so multiply it out, we get 452 cubic meters. Okay. So finding volume is very easy. All we've got to do is remember the formulas, plug in our numbers, use our calculator, and solve.